Chapter 5, Section 1, Uniform Circular Motion. Uniform circular motion is the motion of an object traveling at a constant, uniform speed on a circular path. Here's an example of uniform circular motion. Now, why is this an example of uniform circular motion? The speed of the plane is constant throughout the circle. You notice how the speed of the velocity stays constant at all 4 points. That means that the tangential acceleration is equal to 0, meaning there is no change in the speed throughout the figure. It is important to remember that the time it takes for one complete revolution is equal to one period, which is represented by t, giving us the formula v equals 2 pi r over t. That formula can be used to solve for velocity, radius, and period. So the speed is constant, but the direction is not constant throughout uniform circular motion. Here's an example. The uniform circular motion at velocity v has a different directions at each place on the circle. The velocity vector has been removed from point P, shifted parallel to itself, and is rejoined with its tail at point O. You notice how at every point the velocity changes. So here we have example 1. A car has a radius of 0.29 meters, and it traveled at 830 revolutions per minute. Now, we have to use the formula to find our solution. So first, we use our formula v equals 2 pi r squared over t. And then we plug in our givens, and we get the answer 25 meters per second. But however, we can also solve this problem through dimensional analysis. So we start off with our 830 revs per minute. Then we convert our revs into 2 pi r because that is equal to 1 revolution. And then there are 60 seconds in a minute, and we derive at the answer of 25 meters per second. So whichever way you decide, you should be able to derive at the exact and correct answer.